In this example, you have a water tank that has a shape of an inverted circular cone with base radius 2 meter and height 4 meter. So this is the basic shape that you have. And here you have your base with radius 2 and the height, the total height is 4. If water is being pumped into the tank at a rate of 2 cubic meter per minute, find the rate at which the water level is rising when the water is 3 meter deep. First of all, we know that the rate of change of the volume with respect to time is 2. Take a look at the second line. The water is being pumped into tank at the rate of 2. So here you have the unit, which is cubic meter over time, which is basically the rate of change of the volume. The question says, find the rate at which the water level is related to the height, how the water level is changing. So we are asked to find the dH dt when h is exactly at 3 meters. Remember the general formula for the volume of the cone. It is a third pi r squared h. We know dV dt is 2. We're going to use it somewhere, somehow. But looking at this shape here, we can find the ratio between r and h. But how? The ratio of r to the h is 2/4. Remember that the radius is fixed. It is 2. As the water is pumped into the cone, the radius increases and it becomes close and close to 2. The same for the height. As water pumped into the cone, the height is changing until it reaches to 4. Basically, the ratio r to the h is 2/4, or r is h divided by 2. Why we do that? Because we want to get rid of one of the variables so we can take the derivative of our volume. The volume formula is a third pi r squared h. So a third pi, r is going to be now replaced by h divided by 2 from the ratio that we got to the second power times h. After simplification, volume based on height is pi over 12 h cubed. Now take a look at it. We're going to take the derivative of v with respect to t, which is going to be pi over 12 times 3 h to the second, but we need to have the rate of change of height with respect to time as well. It doesn't disappear. dH dt can be written as 4 over pi h squared. We're just doing basic algebra here. dV dt. But dV dt from the question is given to us as 2. And also height is 3. We substitute everything into dH dt, and dH dt becomes 8 over 9 pi. Using a calculator, it's approximately 0.28 meter per minute. Let us take a look at the summary here. First, we identify information from the question. dV dt, the rate of change of volume with respect to time, is 2. dH dt is missing. This is what we're trying to find. And h, the height level, is 3. We know this formula from before. From the shape of this cone, the ratio of r and h is 2/4 or a half. So r is a half h, or r is h divided by 2. We substitute that into the volume formula, and volume is now just written in terms of h. There is no r anymore here. Now we are taking the derivative of v with respect to time, which is dv dt, pi over 4 h squared dH dt, and then we switch these. dH dt becomes 4 over pi divided by h squared, so you have 4 over pi h squared dv dt. Now substitute everything that we have. dv dt from the question is given to us as 2. h is 3. And then do the multiplication and division. dH dt is 8 over 9 pi, or 0.28 meter per minute.